All right, we're going to continue our investigation of smells with a smell lab in the next class time. So in order to kind of prepare ourselves for a lab of this kind, we need to kind of discuss what chemical reactions are, how they occur, and what catalysts are. Okay, so that's what these notes are going to be about. They're going to help you prepare yourself for thinking about the lab next class. All right, our first question is what are chemical reactions? So in the lab tomorrow, you guys are going to be doing some chemical reactions with different substances. And so a chemical reaction is a chemical change that occurs when substances are going to interact with each other to make new substances, and therefore they're going to have new properties. Okay, and so chemical reactions, when we're talking about big biomolecules that we're going to be working with, occur at the site of the functional groups. So the functional groups are going to be breaking apart in these chemical reactions. So obviously bonds are going to break, new ones are going to form, okay? And in a chemical reaction, they're always written out kind of like this here, okay, with our chemical symbols and an arrow showing the reaction has occurred. So on the left side of the arrow is always what we call our reactants. Okay, so here is our reactants for this chemical reaction, hydrogen and chlorine. All right, and then for our second example, here are our reactants here. We've got propane, and oxygen gas. Okay, so whatever we start with, our starting ingredients are always going to be what we call reactants. And those are going to be on the left side of the arrow. Now, on the right side of the arrow, we have our products. Okay, so our ending products, our ending compounds are called products. So in this first chemical reaction here with hydrogen and chlorine gas to make hydrogen chloride is our product, okay, right here on the right-hand side of our arrow. And in the second one, we've got carbon dioxide and water being the products of this chemical reaction. And we can always see that products are always on the right side of the arrow, and the reactants are always on the left side of the arrow. All right, so you may be wondering, well, how do chemical reactions occur anyway? How do molecules get together to form reactions? Well, there's a theory called the collision theory, okay, that says that whenever atoms, ions, or molecules are going to actually react to form products, they have to collide with each other first. Okay, so that's the collision theory. Atoms, ions, molecules must collide with each other in order to react. Okay, so they can't just, be across the room, go, hey baby, want to react? Hey baby, want to react? No, they actually have to bump into each other. Okay, so there's a couple of caveats to this. So they have to collide, but they have to collide with the correct orientation, okay, meaning that certain sides of the molecule have to bump into each other. And then they also have to collide with the right amount of energy, which is what we call activation energy. Okay, this is an important term, activation energy. So they have to collide. They have to collide with the correct orientation, and they have to collide with the correct amount of activation energy to even make a chemical reaction occur to form a product. So if you think about all these things separately, it's kind of, even miraculous that we can have chemical reactions take place. So down here in this picture down here, okay, so these are some scenarios. All right, so we have reactants moving too slowly. If they move too slowly, then they're just going to bounce right off each other, and they're not going to make a chemical reaction. Okay. If, again, here's one where it says they are facing the wrong way. So the orientation is not correct. If the orientation, again, is not correct, if they, two improper ends collide with each other, again, they're just going to bounce off each other. They get no reaction, okay? It's only if they have the correct amount of energy and the correct orientation that they can actually make a chemical reaction and make new products. So it's kind of cool that they have to have the right amount of energy and they have to collide in the correct little manner in order to actually make a chemical reaction. All right, so that's what that is talking about. Now on the right-hand side here, this is a little graph of energy during a chemical reaction. Okay, and so we've got reactants here. Okay, so the reactants are going to be right here. All right, so this is what we start with, the reactants. So they're going to have a certain amount of energy to them. Now, in order for them to actually collide with the correct orientation and amount of energy that they need in order to make new products, they have to have a certain amount of activation energy. So they have to kind of overcome this slump of activation energy in order to be able to make products at the end. Okay, so that's what activation energy is. It's the energy in order for them to collide and make a new product. Okay, so it's kind of like the hump they need to get over in order to make a new product. All right, so that's important when we do our last question for these notes is how do we speed up chemical reactions? Because sometimes they can take forever. And if we, in our lab tomorrow, we're just, let it sit, let the two chemicals sit with each other, they wouldn't be able to actually make a chemical reaction in a timely process that we can actually observe in a class period. So let's take a look at how we can actually speed up chemical reactions and how this has to do with activation energy. All right, so in our lab we're going to be speeding up chemical reactions using what's called a catalyst. A catalyst is a substance that we add to the chemicals that's going to speed up the reaction, but itself is not going to be part of the reaction. So we're not going to use it in writing out chemical reactions, but it's just going to kind of be there to kind of kick the chemical reaction in the butt to speed it up a little bit. Now the way that it works is that catalysts are going to lower the activation energy required for the reaction to take place. So if we take a look at this picture, we can see that, here's an example. Here's the reactants, and this is the usual hump that they would have to get over in order to make the products. So that's the usual, activation energy required that is going to be required to make the chemical reaction. But if we have a catalyst there, okay, then we can lower that hump. The reactants only have to you have this amount of energy in order to make the products. So it lowers the activation energy required for those, two molecules to kind of collide and actually make a chemical reaction occur. Okay, so in our lab, we're going to use a chemical called sulfuric acid that's going to be the catalyst. And so this is H2SO4 is going to be our catalyst tomorrow. So we're going to add a couple drops of H2SO4 to our vials in order to speed up our chemical reaction that's going to occur. All right, so that's it for these notes, and I'll see you tomorrow for our lab.